Hi, and welcome to the second of our video series of ArcGIS Creating a Basic Map. And in this video, I will show you how to set up the map using the data links I sent out in the assignment. So first, let's go to your Windows Explorer and go down the C drive. As soon as I find the C drive, get rid of documents. There we go, C drive. And open your base data folder. Now this is the zip file that I sent out earlier for you guys to download and set up under C, base data. And then under that, it unfolds into DEM, logo, orthoimagery, et cetera, et cetera. And while I'm here, let's explain a couple of those. DEM, D-E-M, is digital elevation models, and that's things like elevation data, Hillshade, and other types of base maps. Incidentally here, in a sense, we're recording live. Previous videos I've done have been edited, but I'm just going with it. So you'll hear a lot of ums and probably some mistakes as we go. Anyway, orthoimagery is satellite photos. Logos, don't worry about that. That's adopted from search and rescue, and that's for team logos and things like that, but you don't have to worry about that. What we're mostly going to be interested in here is under your Basemaps, and we're going to want to go in a sense to Topo maps. Now, as I mentioned in the assignment, I wanted folks to download all of those zip files and put them into a logical place. And I just created ARC class zip data. So that has all three zip files I posted for download. These are kind of big, so give yourself some time. And if you've got a really slow connection, maybe even overnight for the Tuolumne, both Tuolumne zip files. So at the top here, I'll just tell you what's in them. SNF, Sierra National Forest, roads, trails, and GPS. I was putting in a lot of what we call vector data. A vector is a point, a line, or a polygon. I didn't actually get GPS in there. I'll send those out later. So this has roads and trails for all of Sierra National Forest. The next is TUOL, Tuolumne, CALV, Calaveras, Hillshade, and I'll explain what Hillshade is when we actually use it, and it's 10 meter, that gives the resolution. And finally, Tuolumne, Calaveras, Northeast Topo, 24K mosaic, and I'll explain a little later what a mosaic is. So what we want to do here is we'll unzip each file, and we'll unzip it just to this folder here, and then we'll move each into the logical folder that it should live in. So let's do the Topo mosaic first. In my case, I right-click, and you probably do a right-click. Now my zip utility is ISARC, something like that, and it just gives me the choice to extract here. And if you're using the Windows zip, the native zip extractor, it's probably something similar. So I'll just extract here. Now notice that I have 1, 2, 3, 4, 5 separate files. All of those files together will be a geotiff. I'm sorry, SID, S-I-D. That's another image extension, and it will be geospatially located. When you actually see it in ArcMap, it'll present as just one file. with the file name of O_NE0101, and then you'll see SID. But when you see it in Explorer, you see all of those files. So now I'm going to highlight all of them. And because these are topo maps, we're going to drag them into base data and topo maps. And that's so they're, you know, once again, you want to find this stuff later. So that's why I've sent out the base data example folder. This doesn't have to be your folder structure. We adopted this from ArcGIS, which started using GIS extensively in the mid-90s. And so they've got a lot of experience in how they store and name their files. And in the mid-2000s, well, a little later, 2008 or so, we in Search and Rescue wanted to do the same thing that they did, which is use GIS more effectively in search and rescue. And so we adapted actually their folder and naming conventions. We changed it a little bit. And again, it's just to give you guys a sense of how to store your data. I found that when I was starting GIS, you know, I was just putting files all over the place. And you will save yourself a huge amount of trouble in life if you name your files clearly so you know what's in them, maybe with a date, and put them in a logical place so you can find them again. Okay, now let us do the same thing for Hillshade. Right-click, extract here. And that's going to be the same thing. Notice it's a whole bunch of different files. Uh-oh, I hit the cap locks key, shift, and then choose all of them. And let's put that into DEM. This is a type of elevation model, though sometimes you might actually want to create a subfolder called Hillshade. And then finally, let's do roads, trails, and GPS. Now notice that's got a couple. It's got obviously trails and it's got roads. So I'm going to highlight all of them. Now this is a vector file, and so I'm going to put those into a vector here. Now you might actually, especially as you build your data set, if you build it on your own computer, you might want to actually have a subfolder there called transportation. Roads and trails is considered transportation, of course. So you might consider that. And you want to do that early in life, because if you set up an ArcMap project and it points to, let's say, roads within your vector files, and you later think your vector files are getting really crowded and you want to create one for transportation and put roads in there, then you'll get errors when you bring up previous Arc projects, and they're easy enough to fix. You know, you just right-click, and I'll show you how to do that later. But you just right-click on the file. It'll have a little exclamation point by it saying it can't find the file, and you just tell it where it is. And so it's not a biggie, but it just helps your life if you have it in the right place in the first place and don't move it later. Okay, so now we go to ArcGIS. I've opened a project, and I've got a blank map here. Let's get rid of this. I don't know what that is, but we'll get rid of it. And now we want to start pulling in some data. Now, if you watch the first two videos, you know that you can use an online Basemap. Take a second here to get connected and have them come up. It's kind of slow. Oh, that's not good. Okay, well, who knows what happened there, but in any event, so you've got imagery, you've got topo maps, et cetera, et cetera. The reasons for using your own maps on your own hard drive or network are several. One, you can use your own customized base maps and data, but two, if you have a slow connection, or if you lose power a lot, or you're in an area that just doesn't have internet connection, then you want your own maps. Now, in search and rescue, the latter is often the case. If we're working, in an advanced field post or something like that out of the back of our truck or whatever, we often don't have an internet connection. So I always carry my own map set for an area. But we're not going to use those. Excuse me, I told you this was live. So okay, now first thing we'll do is pull in a base map. Now, depending on what what kind of base map you have and what coordinate system it's in, a best practice is sometimes to actually set the coordinate type for the map. And so for that, you right click and go to database properties, data frame properties, you go to coordinate system, and I have set up as my favorites NAD 83, UTM zone 10, 11, and 12. And if you did your reading and or video on coordinate systems, you know roughly what that is. You don't have to know exactly, but otherwise you'd get them out of projected coordinate systems and UTM and NAD 83, and you'd choose the appropriate zone. Now each zone in the world is on a sort of a master map. California is only zones 10 and 11, and zone 10 is the western part of California, and zone 11 is the eastern part, and just a little bit east of Twainhart, actually more a little towards Pinecrest, is the dividing line between 10 and 11. And it's not super critical that, especially if you have a map that'll span those two zones, it's not critical which one you choose. It happens that the map we'll be using is mostly in zone 11. So I'll choose that, and we'll assign that to the map. Now, the thing about any data you pull in, it will automatically change its coordinate to that of what the map's set at. It does this so-called on the fly, but it does not change the data set itself. It's only while it's inside your project that that it adjusts to what you've set as a base. The next thing, best practice, is we want to save and name our map. And so we're saving it to, we ought to, I have my own projects file set up on a different drive, but in this case, we ought to save it to your GIS data folder, which I just went by. So we open that and notice that I have a projects folder there. So I open that, and let's call that Arc Basic Map Class. And we'll just call this our first map. Ideally, you want to put a date on it. So in this case, it'd be, well, let's do it because we're having so much fun. 2016, this is the best order to do it in, and 10 for the month and 18 for the day. And we just save it. You want to save early and often with with ArcMap because it does not automatically save. So as you go along with Arc, when you get to a place where you're happy with things, then save, because if you don't, you won't be able to recover if it crashes after your last save. Okay, let's pull in our first map. So if you haven't already, you'll want to create a folder connection. Otherwise, within Catalog, you won't see a connection to see GIS data. And and incidentally, you might not see Catalog. And if you don't see Catalog in a tab over here on the right, go to Window, drop down to Catalog, and just click that, and it'll open the tab. Excuse me, the tab. I'm drinking coffee too. So I've pinned this in place to keep it open. To create a folder, you just go to the little plus folder sign and navigate to this PC, see GIS data, highlight that, and you go OK. But I already have that, so I'm not going to. And then the connection appears. So under GIS data, I now go to base data. I go to Topo Maps. And down here, I have a number of maps, and I want 0_northeast because this is what's called a mosaic. And so for instance, notice here it says Columbia 24K. So that's an individual quad, and there's Columbia 24K quad. So that's one 7.5-minute map, a USGS type map. They also, the California Data Exchange Center has what are called mosaics, where they seamlessly stitch together a whole block of individual maps. And so you get a larger set of individual quads at 1:24K. And it doesn't take that much longer to download those. And in the next video, I'll show you how to do that. Anyway, we'll use, this is the northeast quarter of section 0101. So we pull that in. And so there's the area it covers. And I'm using my mouse wheel to scroll in. You can also use the magnifying glass here. And let's zoom in on, I can't even quite see where we are at the moment. So we are Wheeler Flat, so that's more up towards the crest. Okay, well, let's just go with that for the moment. Now, let's bring in some of that other data. Let's bring in some of the vector data. And, oh, that's right, we had Hillshade. That'll be fun. Let's do Hillshade, and then we'll break and go on to the next video. So here's Hillshade. And we want to put that above the map, the base map. And there's some who would argue you put it below, and I'll explain the reasons for that here. And let's use the hand tool. Notice that the hillshade extends only so far, so it's in a big block. So notice that it completely covers the topo map. But what you can do is you can use the effects tool, and to get to the effects tool, you right click and you go down and you choose effects. I had it on, so now I'm turning it back on, and that puts us up this tool here where you can increase and decrease things like brightness or transparency and some other features that will, or effects that will act on individual files you've got. So right now, let's go to we want to work with the Tuolumne Calaveras Hillshade, 10 meter. And what we want to do is adjust the transparency. So we're going to make this more transparent so you can see the topo layer underneath. So I put it at about 50%, and you can fiddle around to see what works best for the area you're in. But notice the effect there. Hillshade is created to show the sun at an angle in the northwest, and so it applies shading to certain slopes to give a little bit of a effect of a little bit of a 3D effect on a one-dimensional map. So here it is with Hillshade, and here's just the flat USGS map. So this not only makes them a little more aesthetically appealing, but makes them pop out and allows your people to get a good sense of the terrain. Those of us who've been using USGS topo maps for years can kind of look at a map and see which way the drainages go and so on. But this really helps, I think. Okay, I'm going to stop here, and next we'll go on to vector graphics. So I'm going to save, and now we'll stop the recording and see you in video 2.